Hello, my name is Bill. This video is about my program for the Mandelbrot and Julia sets. So I've shown earlier versions of this program in earlier videos, but now I've got the Julia set added to the program, so I'll go through the program again. But first, let's play with the program. So this is a Julia set, so I can zoom in. So I've got some presets here, and I can press keys for different Julia sets. For some reason they don't come out in the center of the screen. I think that works if I start the program from scratch. So the program starts in the Mandelbrot set. So for my presets, there's the one I started with. Let's go back to the Mandelbrot set. Press the M key. Yeah, it's not centered, so I'll have to look for that in the code. Can zoom in. So the Mandelbrot set, in a way, is a map of the Julia sets. So let's see if we can find a Julia set for this point here. So I click there, so it should zoom in. Then I'll press J to get the Julia set. Now we can go look at the code. So I had the Mandelbrot function in the earlier version, but I changed a few things since the previous video. So I've simplified this a bit. So then I added the Julia set. So the difference with the Julia set is this C value. So in the Mandelbrot set, the C takes on the value of where you're at in the image. So you're scanning a region of the complex plane. So with the double loop, cover do this loop for every pixel on the screen. So the C changes for each pixel, whereas for Julia, the C is constant for the whole image. So what changes in the Julia set is the start value for the Z. So the complex number that corresponds to the pixel on the screen. So I added a drawing mode class. So far I have none Mandelbrot and Julia. In their fractals class. So I added the drawing mode. So the program when the class is first created, or in the Mandelbrot mode, and I set default value for the C for the Julia set. So I had a problem with palettes in my program, that when I set for higher iteration values, the palettes didn't work. What it turned out to be is I was using unsigned integer 8 to store the values. So with 8 bits, your maximum value is 255. So when my iterations was larger than 255, then the numbers stored here were chopped off or wrapped around or something. So the center of the Mandelbrot set would no longer be black, like it should be. So now that I set that to unsigned integer 16, I won't run into a problem again until I try to exceed 65,000 and something for the iterations and the number of colors. So I added a function so I can read the setting for maximum iterations in the main program. The update corner, move center, zoom in, zoom out, zoom right. So those zoom point, mouse down are all the same as they were in the previous video. There might be some little tweaks, but they're pretty well the same. So then I added the Julia set function. Then in redraw, if the drawing mode is Mandelbrot, it calls Mandelbrot set. If the mode is Julia, then it calls the Julia set. So I have my presets for the Julia set that I got from the book Programming in C by Roger T. Stevens. Then I have a draw Julia function. Yeah, this one is when I press a key, this function gets called to select one of these settings from the table. So that's the number of iterations, and then the C value, the real part, the complex part. And I changed the caption at the top of the screen to Julia. Then I create the C value from that table. Set the drawing mode to Julia. So to use that value for the iterations, use this line of code. But since I'm using my preset value, which right now I have set to 1024, so it's much bigger than he used for any of the ones in the book. But the book's from 1989, so computers were much slower back then. Then I set corner in the scale. I should probably change that. I changed it from the Mandelbrot set, the default scale, so it would fill more of the screen. Yeah. So it uses most of the height. I don't have a proper user interface because that's not easy in pygame, and since I'm just playing around and this code's for myself, I don't really need a fancy user interface. Then I can set the mode. So if it's set to Mandelbrot and I want to change it to Julia, then it sets the mode, sets the C value for Julia to the center value for the Mandelbrot set. So I don't think I showed that when I was running the program. Yeah, I probably did when I talked about the Mandelbrot set being a map for the Julia set. So I'll switch to Julia mode. So it was that point I clicked on the Mandelbrot set to become the center of the display is what gets used here for the C value. And also didn't change that. So I had changed it in the default settings when I started the program up. So the first time around used that value. So if the drawing mode is Julia and I'm trying to set it to Mandelbrot, then it changes these values here. And my mouse code is pretty well the same as before. And then I have added a save screen. Originally I was using frame number, but that's not used anymore, so if screenshots directory doesn't exist, then I create it. I used the current time to create time string, and then the file name is what's Mandelbrot set. Then I use the time string. If it's Julia, I say Julia, then the time string, and then save the screen to the file name. And the load palette, probably the same as in the previous program, but previous video, but I don't use that anymore. The apply palette is the same. So in the earlier video I talked about how this code is very fast because you have one line of code which handles every pixel in the image. So the looping is done inside the NumPy libraries. So now I use this create palette instead of the load palette. So I set the start angle on the color wheel and the portion of it. So right now I'm starting at the beginning and using all 360 degrees. So for the whatever size of the palette I want, go to size -1 and calculate the hue and the distance around the circle. It's I divided by the size of the palette. And you scale it using these two values. Scale it and offset it. So then you use the hue value, which needs to be from 1 to 360. And then that's the saturation. And L, that must be the lightness. So 100 I think would be white and 0 would be black, so 50 gives you the maximum brightness for the color. And then alpha, that's how transparent it is, or how opaque it is. So I have it for 100, so that's completely opaque. And then the palette entry, I get the RGB values out of that. So it makes it quite easy to convert from hue to RGB values. And then the last entry of the palette is set to black. Now if you want to use a color gradient instead of the color wheel, set the size of the palette, start color, end color. So you create the array for the palette. So it's the size of the palette, so by 3. So you got 3 bytes for RGB values. So R1 split out the RGB values from the color, and for color 2. So then you use this numpy linspace function, which gives you evenly distributed values. And I do it for size -1. So do that for R, the red, the green, and the blue. And then stack that into the palette. And then make the last entry black. So the last entry is always black because you want the interior of the Mandelbrot set to come out black. See, that's where the problem arose with when I was using 8-bit values in the Mandelbrot function. But I was making palettes larger than that. The largest value in that the Mandelbrot function was giving me was 255, which would never be the largest entry or the last entry in my palette if my palette was larger than 255. So the main function so I just create the palette on startup. But if I want to use the gradient palettes instead, so I'll say I want to go from red to blue. But you don't see much blue until you zoom in a lot. you ever see blue. Actually, I never tried going the other way. Go from blue to red. So it starts at green. There you're starting to see the red. Go back to my color wheel palette. I was going to show you some variations with that, and I forgot about that. So with the using the full color wheel, get up into the violet here. So say I only want to use half of the color wheel. So if you get these numbers wrong, the program will crash. So, and start halfway around. So if you're doing a proper program, you do error checking. Let's try a Julia set. So if you do a high number of iterations, the detail comes out quite fine. So, and then if you hit the wrong spot, you might not see a Julia set. So let's say you want to start at 60 degrees. So that gets into the yellows. We have a Julia set here. I don't see much. Oh, there is something there. Where was I? Yeah, so then whatever palette was created or loaded, and apply that to the pixel data from the Mandelbrot set. And I have the mouse functions which are used by the zooming code that I showed earlier. And I also can do plus to zoom in and minus to zoom out. I didn't show that this time, but I showed that in the previous video. And an S for to save the screen. And J switches to Julia mode. Changes the screen caption. M switches to Mandelbrot mode. Changes the screen caption. Then I use these keys to get my presets for the Julia set. So I run out of numbers, so I started on the next row of keys. Then display and update the fractals. I was just wondering if the update should come before the blit, but since we're doing this 60 times a second, it doesn't matter too much, I guess. And I had the frame number when I was using that for my file numbers, or my file names. So I would come out with file names like this. Then when I change to the using timestamp, and originally I was just using the name Julia, so it would overwrite every time I saved it. And my original program, since I was just using the name Mandelbrot, when I saved, and I would edit the file name, change the file name, so it wouldn't overwrite. Well, here, if you want to see a preview of my next video, so I'll scroll through the code in case you want to pause the screen and look at it in more detail. I never put my color wheel back. Does it still work? So that's all for this video.